of the three versions of the cosines that we're going to wind up using. Now, remember, all three of them are the same thing, it's just a matter of which letters we're repeating as they go through. When we look at it, we're given angle A, and we have to find the side A. So we'll write out the law of cosines in terms of A. When you do that, you have your A squared is the B squared plus C squared minus 2BC cosine of A. From here, we're solving for the little a squared, which means we know everything on the right-hand side, so we just fill in the blanks. 23 squared, 28 squared, 2 is 23, 28, it's over a little bit, and that's the cosine of 103. Now remember, all of that's going to equal a squared. Right? Now is when you put it all in the calculator. 23 squared plus 28 squared minus 2 times 23 times 28 cosine 103, I believe. And hit enter. You get some crummy decimal. That crummy decimal is equal to a squared. When you're trying to find the side length with law of cosines, you have to take the square root of all of that junk. Square root, answer, and little a is now 40.03. Okay. So once you get that side, now you've got your angle and your side opposite. You use it, in this case, we have to use it one more time to get another angle. I always tell you guys to find the next largest angle every time. So which one are you going to have to find, angle C or angle B? You're going to find C, because 28 is the larger of the sides across. So you use your sign. 103 is to the 40.03 as the sine of C is to 28. By now, we all know that this 28 just needs to move over here. So what people are usually doing is just erasing it and rewriting it here. Type all of that in. Fraction bar 28 sine 103 over 40.03. Crummy decimal is the sign of an angle. Anytime you're trying to find an angle, that's when you always have to use the inverse function, whether it's sine or later on when we did the cosine ones, we still did the same thing. Second, sine of answer. And it gives us our next angle at 42.96. So if you're doing this right, you're probably within a couple of decimals as you're going through. So angle B would have to be 0.0445. So is it 4404? Is that right? Somebody help me out here. 4404 on that last one. I'm just trying to guess it. My next would be 45. No, I'm going to 90. I'm sorry. That'd be 34. 3404, right? Yeah. I was thinking 90 degrees for some reason. I was trying to go 45. Oh, 45 plus 45 is 90. I'm like, no, we've got to go to 80 for 180. So, okay. And that's what you do for that one. All right. Then the other style of cosines is when you have all three sides. Remember, whenever you're given all three sides, no matter what, you always have to find the largest angle first. Okay? So that was the one that was on the back of that sheet. Just not scroll. And it was this. I don't think you guys didn't have the actual copy. Did I have the big? Yeah, I did. No, I didn't. So when I posted, I drew it on there, so at least it was there. So in this one here, you get sides of 14, 10, and 19. What angle is this forcing you to find first? No. Forcing us to find A first, okay? So as we go back and we relabel, little C, little B, we got to find angle A. So you write it out. And fill in the blanks. Now remember, whenever you're trying to find the angle, since that's part of the cosine part, I want you guys to split it up and to simplify the first three pieces we have. Okay? What I've been doing throughout the day today when we have this setup is I've been kind of just grouping it. That way you know, simplify those parts as you go along. Square the 19, you get 361, I believe. 14 squared and 10 squared was 296. Yell if I'm wrong. I'm trying to remember this from earlier. And then 2 times 14 times 10 is 280. And remember, when you have this set up, you cannot combine these two, okay? Because there's a variable with the cosine. You cannot combine those two. It will be wrong. If you were doing that, you were getting domain errors, and that's why everything was wrong. Okay? You cannot combine those parts. You have to work backwards out of this. You have to subtract the 296 first. I believe this was 65. And then you had to divide by the negative 280. That fraction will give you the crummy decimal. That crummy decimal equals the cosine of something. So what we need to do is type that in the calculator, get the decimal equivalent, and then inverse it. So 65 over negative 280. Inverse cosine. The answer at 103.42. If I did that right. That gives me A. Go to my diagram. Okay. Now we use law of sines, but what angle do you find next? B. Yeah. We use it to find B. So you write out your law of sines then. Sine 103.42 is 219, as the sine of B is 214, which means the 14 just goes up front here, and you're back to the calculator. Inverse sine, and 4578. So 180, 3.42. Leaves me 30.8%. Those numbers sound right, because I think that's what we got last time. When you're using the law of cosines, it's not any more difficult than the law of sines. The only trick is when you're trying to find that angle, you got to make sure you break it into 3 parts and work backwards. You cannot combine them. That's where most of you guys will make mistakes. You'll get domain error and say, oh, it doesn't work. Yes, it does. I know I kind of went through the 2 that I've been asked the most of throughout the day. Did you guys want to look at 3 or 1, or are you guys all right? They're all kind of, the other 2 are basically the same. It gives you the angle. I think those were both angle side angle, weren't they? Yeah, those were both angle side angles. So all you had to do was find that third angle, then you got law of sines. So it worked, or find that side, and then you got law of sines. Okay. So, like I said yesterday, the main next step of this, of these types of problems, just like we're doing with right triangles, is that now we have to kind of with our own pictures, draw the diagrams. And a lot of times, when we do this, the workload of the problems aren't as much. So, I'll show you guys what we're looking at today here. Leave one for Morgan. Make much you don't want to. Because you see all block sign, of course, I'm going to see this. The 2 of them are pretty good fine. Is there one? I think for some reason I felt like this one.
As you guys get this one, please do me a favor right off the bat. Cross out number 4 and cross out number 6. Okay. For the geometry class, there's really no reason for us to get into that complicated of a style of one of these problems. So the rest of these are relatively simple. There's no reason for us to do those two because they're just kind of goofy. 4 and 6. So what I want to do here with you guys, though, is get back into the idea of what do you do when, how do you draw these types of pictures, how do you interpret the information into whether or not you have to use law of sines first, or you have to use law of cosine. Okay. Remember, I'm not going to make you guys memorize the formulas. You guys just have to know when do you use what. That's kind of the trick. Okay. So let's look at the first one. The first one says, during a figure skating routine, Jackie and Peter skate apart with an angle of 15 degrees between them. Jackie skates for 5 meters, Peter skates for 7 meters. How far apart are they? So that means we need figure skaters. So we have our figure skaters. That's close enough. I didn't have a male figure skater picture. So she's doing flips. Hey, don't you do flips while you're figure skating?
No.
Well, why can't you? Doesn't anybody do flips?
You sound very talented.
Some. Oh, is this for later? Might be for next hour. So, anyway, we know that these two people start at the same spot, right? Actually, but well, we're gonna flip. We're gonna change what we'll make her go left. It's a 5 minutes instead of spinning. So we'll flip around the axis, and she'll spin slow. But she's upside down. So she's doing this. There. So they're spinning, having a good old time. Because why wouldn't they? This is the whole point of word problems, because you can have a little bit of fun with it, right? Now, do they start at the same spot? If you're twirling, are they starting at the same spot? Well, obviously. See you later.
Oh, wow.
So she went this way. Anyway, so they start at the same spot. One person goes this way, the other person goes this way. How many degrees are between them? 15. Okay. So it's 15 degrees here. Okay. One person went how many meters? One person went the other one. Does it matter? Honestly, in the grand scheme of things, does it matter which one's which? No. So we'll put 5 and 7. The question was, how far apart are they at the end? So basically what we've done is we've created a triangle trying to figure out how far apart they are now. Well, when I look at this, is it side angle side, side side side, angle side angle, or side side angle? Which one are you going to use? Law of cosines or law of sines? Cosine. Now, I haven't labeled anything here. But we have to find a side length, don't we? But we know an angle, right? So does it matter what letter I call this? If I call this angle A, this makes this what? Little a. So wouldn't the other two just be arbitrary, B and C? Because if you think about it, when you put the B and C here, if I'm adding them, the order doesn't matter. When I multiply them, the order doesn't matter. So I can just arbitrarily just give either one, okay? So what I'm doing here, if I wanted to call this angle B, this would be little b. If I want to call this angle C, this would be little c. Any one of those three would work. Just label it and make it consistent, right? So now I would write it out. Yes, sir. Because the question, I believe, the last sentence was how far apart are they? So they've gone 5 and 7 at that angle. How far apart are they at the end? Well, little a squared is b squared, c squared, minus 2bc cosine of a. And then you fill in your blanks. 5 squared plus 7 squared minus 2 times 5 times 7 cosine 15 equals a squared. So that means when I find all that, how do you undo squaring?
Huh? What?
How do you undo squaring?
How do you undo squaring? I don't know. I forgot.
Square root.
Yeah, there you go. No.
No?
Yes, it is. Yeah, there you go.
Find it. Anyway, so at this point you would type everything here on the right because you're trying to find the unknown on the left. So in the calculator, we had 5 squared plus 7 squared minus 2 times 5 times 7. Oops, I hit times twice there, sorry. 5 times 7 cosine 15, and I hit enter. This number is a square, all right? All right, I've been having a lot of people trying to inverse that. We're not inversing here because we're trying to find a side length. You only inverse it if you're trying to find an angle. Okay? Plus, if you're inversing something, your decimal is going to be, you'll have no number in front of the decimal, so you can point something. It's going to be less than 1, right? So if you second the square root of that, that gives you how far apart they are, 2.53. Does that make sense? You're shaking your head, no. All right, remember, when you're trying to find the side, you're square rooting. So they are 2.53 meters apart. Is it the end of the world if you don't label it? It's not. Like I said, worst case scenario is going to be when I really care about labeling is surface areas and volumes. Not a big deal. Okay. Not terrible, was it? Does it say to find all the rest of the stuff?
No.
No, all you had to find is how far apart they were. So a lot of times with these log sine, log cosine problems, there's not as much work. All right. Let's read the second one. Second one's talking about a bridge supported by triangular braces. It says each side of the brace has lengths of 63, 46, and 40. Find the measure of the angle opposite the 46-foot side. Correct. Now, do I have to draw the whole bridge? No. All I have to do is draw the triangle, right? So let's just draw a triangle. And again, if I draw my triangle, it tells you what your sides are. So I'm just going to label A, B, and C. It doesn't matter where I put them. And it says sides are 63, 46, and 40. It's asking us to find which side length first, or which angle first. Across from the 46. Am I allowed to find that angle first? No. Which angle do you have to find first? Correct. That's the trick. You have to find the biggest one first. Okay? Remember, law of cosines will do some weird things if you don't do that. That's why I wanted you guys to see this question. Okay? Even though they're asking us to figure out angle A, I can't find that until I find angle C. Okay? Once you find angle C using the law of cosines, then you would just use law of sines to find A. Okay? It's very similar to the ones we did yesterday. Okay? On number 3, do me a favor. I'd like you guys to not do half a mile. Let's change that to 2,640 feet. It's easier to type in with the feet instead of trying to do it with the half part. Then we don't have to worry about an extra fraction. 2,640, because a mile is 5,280. Half of 52 is 26, and half of 80 is 40, so 2,640. Would you guys do me a favor? Can you put that on
26.
the gross papers too, please? What do you want? You see what happened when she ran out here so fast? She's trying to rub it in your face even more. And then, okay. This one isn't so bad. It says two observers are standing on the shore 2,640 feet apart at points A and B. So, what would you draw? 3. You okay there?
Yeah.
All right. I would draw if the two observers at point A and point B, right? How far apart are they? That far, correct? Says they look out at a sailboat at point C. So where should I put point C? At the bottom. The way I drew it, I draw it at the bottom. Could you draw it above it if you really wanted to? Would it be okay?
Yeah.
Sure. It then says the angle from A to C is what? 63. What's the angle from B to C? Side angle side, side side side, angle side angle, side side angle. What is it? Which means what are you going to use?
Science.
Science, good. In order to use law of science, what do you have to find first, though? Yeah, you got to find C. Okay. So how many degrees are in a triangle? Right, you're right. You take 180 and back out the other 2, and that's how you work. Real fast, number 3 and then number 7 on the other side. Number 7 is basically the exact same problem, just different numbers. Okay? They're basically the same side picture. On number 5, you guys know what it means to be due south of something? Yeah, basically. If you think about a compass, when you have a compass on a map, it's usually north, south, and then, I'm saying it in my head, east and west, like this. North and south. South is, if it's due south of something, it means it's straight below where you're at. Okay? So if it says that Orlando is 178 millimeters due south of Niagara Falls on the map, not really in real life, it's not very far. You would just draw, well, which one's above the other? Where's Niagara Falls, above or below Orlando? Above. So I would just say, oh, Niagara Falls is here. Orlando is here, due south. According to the diagram, it says how far are they? Is it 178, I think? Then it says Denver is 273 from Orlando and 235 from Niagara Falls. Denver. We've all looked at a map. Is Denver to the east or the west of Florida? West, so I just gotta move to the west of it. Does it matter really where I put it? Call it Denver, go through here. That gives you angles, all right? Or it gives you distances. 273 and 235. I think it asks us then to find the angles at Niagara Falls. So if I need to find the angle at Niagara Falls, can I do that first? If I need to find the angle at Niagara Falls, do I do that one first, or do I do Orlando first? Okay. Yes, ma'am. Honestly, no. It would. As long as they're connected this way, you're going to be okay. I was just trying to say that because Denver's to the west of Orlando.
Yeah.
You put it the other side.
So like
Yes, because it says Denver to Niagara was 270. Oh, did I have them flip? Oh, I'm sorry. I misread that. I'm sorry. My bad. I had them flipped. I didn't realize that. I'm sorry, guys. So this was a 235. This was a 273. So it was. You do find Niagara Falls first. I didn't even catch that I did that. When I was reading, I think I read Niagara Falls, Denver. I thought that was the first one instead of. Oops. So now can you find Niagara Falls first? Yes. I can find it first. That's how you do word problems for us. They're really easy. Okay. So tomorrow I'll have you guys do those. And then the other part was I have 4 of the other questions that we did from the past couple of days. One of each style. So there's one angle side angle. There's one side side angle. There's one side angle side, and there's one side side side. Those will be again very straightforward. Solve all for the missing pieces. Grab one more before we finish. Thank you. And we'll go from there. Again, I cannot recommend highly enough to write down the formulas for the law of cosines, law of sines on the sheet as you're doing it. That way they're right in front of you as you go back. So that way also you know when to use what. Okay. On this one here, I'm pretty sure there's nothing that's crazy. I tried to make them as clean as I could. Now I'm going through. Thank you. Alright? Please, give them a shot. I will click these 4 questions, and I think on the other one, we basically started all the other word problems, so those should be real quick. I'll click both of those tomorrow. We'll take our quiz, and we'll be done with trigonometry stuff for like the whole bulk of the year. It will still show up from time to time, like right side will still show up. SoFITOA can still show up every once in a while, but they're relatively straightforward.
Well, are we taking it this week?
Probably. Because what I'll have you guys do is do your chapter 8 test, the one that you, the regular SoFITOA test that was Monday, do that one tomorrow, then this one you don't do Monday.
Okay.
That's what sucks when you guys keep it from so much school as it is.
My bad, we were sick.
Yeah, whatever. Things can be crap. I don't know if you've ever noticed that I've done that before. Yeah, I've never been like.
Sorry.